Well, hello and welcome YouTube. Mr. Robinson back here with yet another brand new exciting video, all math basic course. And as always, it is an honor and a privilege to be serving you here today, as it is every day here in my virtual classroom. Step on inside and enjoy the fight. It's about to get nasty up in here, guys. Chapter 4 test and cumulative assessment coming up. I believe 13 questions in the Chapter 4 test, 9 questions in the cumulative assessment. Might go quick, I'm not sure. But as general, less teaching, more doing in these problems. So obviously, I might have to do some things in the calculator and get your graphing calculator up and ready. If we have to graph some things, we'll get those ready as well. Jump to the description section down below and find anything that you need to find down there. This PDFs will be separate. Chapter 4 test first. Chapter 4 cumulative assessment next. Remember, chapters 1 through 4 are all involved. That might include graphs, right? And everything we've done in solving equations previously. All right, we're going to go ahead and get started. Sorry for inciting violence among you folks over here learning math. Write an equation in slope-intercept form of the line with the given characteristics. Now, they are not requiring how we start this problem out, but for the first one, you have a slope of 2/5 and a y-intercept of -7. Straight up, y equals mx plus b is waiting in the wings. Y equals 2/5 x minus 7 is it. That's the answer. I'm done. So nothing else I need to do there. Number 2 is, I'm not going to say it's the same kind of problem, not at all, but we're going through the points 0, 6, and 3, -3. And this is our y-intercept right here. This is our b value. B is 6 because that's the value of y when x equals 0. Now your slope needs to be determined by rise over run kind of stuff, right? So we're running from 0 to 3 and we're falling from 6 to -3. So the slope's -3 there. Now that we have our slope and y-intercept, we can write equals -3x plus 6, or y equals mx plus b, like so. So like I said, less teaching, more doing. I mean, I'm teaching it, but I'm also going to go through the problems. You know how fast I went? I forgot to put this on number 2. Number 3. Okay, parallel and perpendicular are for 3, 4, and 5. So on number 3, parallel to the line, y equals 3x minus 1. And we got to go through the point -2, -8. Now, parallel will mean we have the same slope of 3. To go through -2, -8, we have some options. The one I'm going to do on this one, I'll use point slope form to begin with. Y minus y1 equals m times x minus x1. Notice the sign changes. But they said slope-intercept form ultimately, so I do need to distribute the 3. And I can now subtract 8 from both sides like so. So we'll get y equals 3x minus 2, and that will be it regardless of whether you did this form or you started out a slope-intercept form. Number 4, maybe we start out in slope-intercept form this time, if that makes sense. If it doesn't, I'm going to go ahead and do it. Parallel to y equals 2/3. Oh, hold on a second. Okay, never mind. Oh, okay, well, this problem's going to be a little different. Parallel to y equals 2/3, and we're going to through, hold on, parallel to here, and through the point -4, 12. Okay, so here's the thing. The slope of this guy is 0. And if you know anything about a slope of 0, that means you're going to have a constant function. If this y value is 12 here, then y equals 12 is going to be your equation. It's a horizontal line. Y equals 0x plus 12. I don't have to do extra for that one. That one's just a little unique and different there. Number 5, this time I'll try and do slope-intercept form. I think this one's going to be different. Meaning all of them are slope-intercept form, but I'm going to go through the slope-intercept form process. So perpendicular to y equals 1/4 x minus 9, and we're going to pass through the point 1, 1. So this time, first of all, our slope that we need, we have a slope of 1/4, but our slope that we need is going to be the opposite reciprocal, -4/1. So this time I'm going to write it like this, okay? We need an equation that is y equals -4x plus b. I have an xy right here and 1, 1 that I can substitute here. 1 is -4 times 1 plus b, and we solve for b. If I add 4 to both sides, I get a b value of 5, and that's what goes into my equation there. So we got this b, we got this m. We're going to say y equals -4x plus 5. I'm writing a little too fast. Let me do that again. Y equals -4x plus 5. And I could have done the point slope form version. This time I use slope-intercept form. It's kind of an either-or thing. I want to keep using them as often as I can. Okay, number 6 and 7, write an equation in point slope form with the given characteristics. So this time we are using point slope form. y minus y1 equals m times x minus x1. We have a slope of 10, and we have a point that we pass through that's 6, 2. This is straight up as direct as it gets. Y minus y1 equals m times x minus x1. You're done. That's your point slope form. You don't distribute. This is point slope form. This is what we do out of it. And the same thing on number 7. The difference on number 7, however, is we don't have the slope yet. And there's more than one potential answer. And I'm going to write both of them. So we go through the points -3, 2, and 6, -1. This time I'm going to use the slope formula. We haven't seen that together here yet. I got a y minus y1 over x minus x1. That's -3 over +9, or -1/3. So we use this slope with either sets of points. We can choose one as x1, y1, or the other as x1, y1. It's kind of a your choice thing. If this is my x1, y1, my equation will say y minus 2 is, here's my slope, times x minus -3, but we write x plus 3. There's an answer. We can also use this one, y plus 1, because that's y minus -1, is -1/3 times x minus 6. And the reminder of what this thing does, besides the fact this is point slope form, and we haven't really graphed out of it very often, if at all. If I rewrote these in slope-intercept form, which I could, but I'm not, if I rewrote them in slope-intercept form, it's the same equation. It's the same line. It's the same line. And there it is. Number 8. The first row of an auditorium has 42 seats. Each row after the first has 3 more seats than the row before. So this sounds like a sequence kind of thing. You might not know it from these, but I've done a lot of word problems like these ones before. This would be out of section 4.6. Find the number of seats in row 25 and which row has 90 seats. So in order for us to do this, I'd love to come up with a rule for this. Our sequence looks like the first row has 42 seats. The second row is 3 more seats than that, 45. The third row is 48, etc. That actually doesn't matter to me. What matters is the information they give us. The first row is 42, and then the common difference is 3. 3 more seats than the row before it. Those are the things that matter to me to make an equation. A sub n equals 42 plus 3 times n minus 1. Now, this is a formula we've been using before. Did they ask us to write an equation? No. But they said, find the number of seats row 25, which row is 90 seats. So instead of like recursively adding 3 each time till we get there, let's use this set. Now I can simplify this if I distribute the 3 and then combine like terms, and I get 3n plus 39. So with this rule, we can now do the following. Part A, find the number of seats in row 25. If n represents the row, here's row 1, 2, 3. These are our n values. Row 25 is going to be A sub 25. So we're going to do 3 times 25 plus 39. That is 75 plus 39, or 114. There are 114 seats in row 25. That's part A. Part B says which row has 90 seats. This is where you now find out, you substitute 90 for A sub n and find the n that goes with that. So this is where my equation is going to be helping me on these ones. So I subtract 39 from both sides. And yeah, listen, you could do that recursion thing, but that's not the point. The point is working them out this way. Please follow that. Divide both sides by 3, you get 17. So what does that mean? N is the row number that we're talking about. So row 17 has 90 seats. Row 17 has 90 seats. Number 9. The vertices of a quadrilateral, what section is this? Are J, K, L, M, those in a this is the parallel perpendicular. So let me get a graph thing out of this. It's not required. In fact, you know what? Let's not do the graph out of this. I think it's a little bit better that we're kind of looking at these in a, we're calculating them. So let me write these out. J, K. Now we do know it goes from J to K, etc. So J is at 1, 7. K is at 6, 4. L is at 2, -6. And M is at -3, -3. Okay, we have to come up with 4 slopes. We need a slope for segment JK. Now, that's a rise over run kind of thing, right? From 1 to 6 is 5. From 7 to 4 is -3. There's my fall. The slope of K to L. Let's go from 2 to 6. From 2 to 6 is a run of 4. from -6 to 4 is a rise of 10. That is 5 over 2. As long as I did it right. I just want to make sure I did it right. From L to M. From L to M is, and then we have to do from J to M. From J to M, because that's just how it works. From L to M is going from -3 to 2. That's a run of 5. And -3 to -6, that's a fall of 3. So -3 over 5. Hey, look, those are the same. That's important to call out later. J to M, from -3 to 1 is a run of 4. And from -3 to 7 is a rise of 10. So 10 over 4 is 5 over 2. Okay, now we don't have the drawing, but the idea of a drawing, whether this looks exact or whatever, J, K, L, M, is J and K are opposite each other, L and M are opposite each other. So here's J, K, and here's L, M, opposite of each other. Obviously not the right drawing, but they have the same slope. Therefore, these are parallel, which is important. KL is here, JM is here. Those are opposite each other, and you can tell here they also have the same slope. Those are parallel. Now, what we can see out of this is they are parallel, but they are not opposite reciprocals. If this was 5/3 and -3/5, they'd be opposite reciprocals, and opposite reciprocals would talk about perpendicularity. So they're not perpendicular, although they are parallel. So is JKLM a parallelogram? Yes. Is it a rectangle? No. JKLM is a parallelogram because opposite sides are parallel. Same slope. That's what we're looking for. It is not a rectangle because opposite sides are not perpendicular. Although they were very close. Kind of, yeah, they were very close. They were not opposite reciprocals, though. Flip fraction change sign. Almost, not quite. Okay. That was number 9. Number 10. We're going fast. Now we slowed down a little bit. 12 minutes in, though. We're going pretty fast. How's the fight? I don't know. Some guy standing there. Must be between rounds. Number 10. Ooh, these are slow problems. Look at that. The table shows the amount X in dollars spent on advertising for a neighborhood festival and the attendance Y at the festival for several years. Make a scatter plot of the data. Describe the correlation. Okay, this is one where time will slow down a lot. I want to see if I'm supposed to use the graphing calculator at all. Write an equation that models as a function of the amount of spend advertising. So, okay, it seems like this is one that we kind of do ourselves. It's not so much using the calculator yet, unless they said use technology, make a line of best fit, things like that. So we're not quite there. But they have the information. I'll leave it over there if that's okay. And I am going to plot points, but I have to work on scale, okay? So my X is, they're going by 500s, and I might as well just honor that. So, like, this can be 1,000 and 2,000, and ignore the 5 for 3,000 and 4,000. I don't care about 5,000. It doesn't go up to there. The Y's go up to as high as 1,100. So if I go with these as 100 here each, that'll be 500 and 1,000. And 1,100 is just another one up from there. I can manage with that, please. Yeah, maybe. All right. So at 500, we have 400. I don't know what these are. 500 advertising dollars, 400 in attendance. Yearly attendance. 1,000. So these are going by 500 each time. So 1,000, and this is 550. So halfway in between. Yeah, this will work. 550 for the next one as well. Then it shoots up to 800. Heyo. And then it goes down to 650. Oh, sad face. 800 again. Hey. 1050 and 1100. Now, these are the ones that are above a little bit, like halfway up, and then the next one up like that. So, doing the best I can with that. You clearly see a positive trend on this. And they say make a scatter plot, describe the correlation. My correlation would be there's a positive correlation. Okay, so with my scatter plot, positive trend, it goes Y goes up as X goes up. So A, positive correlation. Now for B, they say write an equation that models the attendance. This is the thing where I just try and draw a line as best as possible that goes through the stuff. It's like, hey, does that work? I have 4 points above. 5 points above. I want about as many above as I have below. That's kind of one of the things that we go with here. So I'd have to like lean it in that way a little bit more. Now that I have four above, 4 below, is it even spacing? I don't really know. You know what I want to do though is kind of get 2 points that it crosses through as best as possible. This is where you and I are going to have kind of different answers, right? Things are going to be kind of wildly different here. So I'd love to try and get something that's like this. This is where it gets a little far-fetched, and this is where I have a little bit of trouble, guys. So I want to try and force points on this thing, and none of that ever really bodes too well. So let's do this. Let's do like, would this work well? I have 3 points above, 3 points below like that, and that point's kind of on it, and then the other point's kind of like that. I think that one might kind of work well. See, you have to remember, I don't know if that point was perfect on there, but let's pretend like it was. You know, what if I used one that's like boom, like boom skis, but it like goes on it like that? Does that work for us? Few points above, few points below? Maybe. I'm maybe cheating with that, but kind of like if we use that point there and that point there, we pretend like it hits those ones. That's 500 comma 400, okay? And that one was what? 4,000 comma 1,100. Let's use those, right? That's a good trend line there. So for this one, we have to come up with an equation for that, you know? So we use those points. We can use the point slope form, slope intercept form, whatever. Let's do it right here. So part B, I need the slope. Now we're rising from 400 to 1,100. That's a rise of 700 and a run from, and actually these are good numbers this way, from 500 to 4,000, that's 3,500. And this reduces to 1/5. This is nice. I kind of want to use that there. Now my y-intercept I can get with one of a couple ways. We can like plug these numbers in, like 400 equals mx plus b, 5 times, or 1/5 times 500 plus b. And solve for b there. 1/5 of 500 is 100. Subtract 100 from both sides like that. Just like that. You get b is 300. So I'm going to use that, okay? Those are clean numbers. I'm going to work off of that. So this is y equals 1/5 x plus 300. Now, would I prefer the fraction or the decimal? What's this about? Dollars spent on advertising and the attendance of the festival for several years. So every dollar spent increases your attendance by 5. We can say that. Or is it $5 spent? Hold on. Advertising. Oh, the run is 5. So $5 spent for every one person in attendance here. So when I interpret the slope, I'd say there is an increase in one person for every $5 spent in advertising. On advertising? Spent on advertising? I think that's how you say it. The y-intercept is stating if you spend $0, 300 people would still show. What was this? Neighborhood festival. Now, there have been a lot of problems where the y-intercept didn't make any sense. I'd say that y-intercept makes sense. You don't spend any money, people still show up. That's possible. You can't, however, like the review, you can't roast a 0-pound turkey. But you can have people show up in that scenario. Was that part C? Well, that was part C. Oh, I thought that was still part of part B. So that's part C. This is part B, or I started part B up there, I guess. So I think we're done. I think that's it for that set. Okay, number 11. Consider the data in the table in exercise 10. Use a graph. Oh, so we're using the same thing for a graphing calculator. Okay, so perfect. Use a graphing calculator to find an equation for the line of best fit. So now we go to the graphing calculator. So good thing I didn't use it yet. We go to the graphing calculator, and I'm going to type those values into here. Stat edit, and I got the following numbers. 500, 1,000, 1,500, 2,000. Okay, those are our x's. Our y's are for those 400, 550, 550, 800. We spent more money and we lost people. What's going on? Why would we spend more money the next year? Actually, we don't know. I don't know if this is literally an increase from one year to the next. It just shows. It doesn't show time. It just shows attendances. I guess that's what that means, though. Okay, so those are the numbers there, and it says use a graphing calculator to find a line of best fit. So now we got to do, let me turn diagnostic on here first. Catalog D, because this will give me my R and my R squared. We might need those later. Diagnostic on. Make sure you do the same. My calculator resets every time, though, so if you already have yours on, great. We got to do stat, calc, and a linear regression for that set, and here's what we'll have. So our equation will be, this is number 11. I'm going to round to 2 decimal places. So this will be y equals 0.19x plus, let's say, 309. That'll be our part A. So I'm writing this as my equation here. Boom. For part A. Part B says identify and interpret the correlation coefficient. Now that's the R value, not R squared, but the R value. The R value is 0.943 about. That indicates a strong positive correlation. That means there's a good link between our advertising dollars and the yearly attendance. So 0.943, there's a strong positive correlation. And again, between those two things. I don't know if I should be saying that, but strong positive correlation between the two things. All right, part C. What would you expect the scatter plot of the residuals to look like? Scattered. Basically, if there's a strong positive correlation, first of all, there's no significant pattern in the set. It'll just literally scattered. But there should be as many above as below. I mean, our graph did that, right? But this isn't the residual graph. But there are a couple points above, a couple points below. I think they always said even disbursement. So evenly dispersed about the horizontal axis. Evenly dispersed residuals about the horizontal axis. And pretty close to it. And pretty close to the axis. Right? Relatively so. I mean, everything is relative to this. If you're a couple hundred off, it might be relative to these values. Part D, is there a causal relationship in the data? Explain your reasoning. You have to think about the fact that you spend more money, more people could come, right? But that's not necessarily the only thing that happens. In fact, there was one time that we spent more dollars and less people came. $2,500 spent, but less people came. So, there may be a relationship, but of course, guys, there are a lot of other things that can link to this, a lot of other factors. So I'd say a causal relationship is possible, but there are other factors in play, right? Word of mouth, such as word of mouth, how good the festival is, the quality of the festival. Population, time of year. I guess they said it's the same time. Well, I don't know, neighborhood festival. I don't know. So just things, right? One can be a part of it. It's a factor. And honestly, that's what the R squared, we haven't talked about R squared, guys. That's what R squared is all about. R squared of 8.88, think of it like a percentage. That's like 89, right? It means like 89% of the relationship can be explained away. That link can be attendance can be explained away by festival advertising dollars. The other 11% can be explained by other things. So there is, I think, a little bit of cause and effect there, right? But some other things maybe not necessarily. All right. Actually, that's still not necessarily causation, but it says how much of the strength is related to that versus something else. Part E says predict the amount that must be spent on advertising to get 2,000 people to attend the festival. So for that one, let's use our rounded values that we had here. Otherwise, I'm going to run into a lot of trouble with it. So 2,000 people to attend would be Y. Let's set 2,000 equal to, this is estimated anyway, 0.19x plus 309. Now, the one thing I want to mention here is 2,000 is outside of our set here. That means this is an extrapolation. I don't know if we can have confidence in this being proper because we haven't seen anything near this number before. But this is the only model we have to go on. It's a pretty strong one. So we'll go ahead and state that maybe this is how it works. Is that 1691? 17, I think so. So divide by 0.19, and if this is a decimal, that's okay. We're going to round. So this X value is about... This is advertising dollars, by the way. I can use dollars and cents, but I'm going to use 1691 divided by 0.19, and I'm getting around, oh, that's actually exact, 8,900. $8,900 advertising dollars. Boom, is what I'm getting off that one there. Now, that is based off my line of best fit. I did use a rounded value, but that's based off my line of best fit. So I'm going to trust it. That's probably what they wanted us to use and get. All right, number 12. Let A, B, C, and D be constants. It says determine which of the lines, if any, are parallel or perpendicular. Explain. Okay, this is interesting. This is a chapter test doing chapter test things. So line 1, we got y minus c equals a times x. Now, this is all a matter of getting y by itself, guys. I'm going to add c to both sides. It's clearly acting as like your y-intercept here. It's some constant. Ax plus c. That means the slope of line 1 is a. Slope of line 1 is a. It's your m, right? mx plus b. There it is. Line 2 says a times y equals negative x minus b. To get y by itself here, we have to divide everything by a. We've seen this before, but let's see how good you are with this still. That's a negative 1x over a. So we can write it as negative 1 over a times x. That's the way we should write that, minus b over a. So the slope of this one is negative 1 over a. Slope of line 2, negative 1 over a, which is important in comparison to line 1. We'll talk about that. Line 3, ax plus y equals d. None of these were in slope-intercept form, but let's subtract ax over here. And remember, that would be your term with the slope on it. So let's write it first, mx plus b. Boom, like that. The slope of line 3 is negative a. So how do these compare? None of them are the same, so none of them are parallel. A and negative a are different, things like that. Negative a, negative 1 are different. We do have an opposite reciprocal, however, in lines 1 and 2. This is a, or a over 1, positive a over 1, and this is negative 1 over a. Those are opposite reciprocals. They are perpendicular to each other. My explanation is what I just said out loud. They're opposite reciprocals of each other. They're perpendicular. Line 3 has no parallel perpendicular with the other lines. Okay, number 13. Yeah, that was it. Number 13, the last one in the chapter test portion. Write a linear function h with the values h of 2.5 equals negative 1 and h of 3 equals negative 6. So this is like f of x, only it's h of x here. So no different from what we would have done at the time. Let's go ahead and rewrite them as like ordered pairs though. So 2.5 comma negative 1 is a point, and 3 comma negative 6 is a point, like that. So let's see here. I got a slope of y2 minus y1 over x2 minus x1. On the bottom, that's 0.5. The top, what's that, negative 5? That's times 2, so that's negative 10. So I got a slope of negative 10. For y-intercept, let's go with point slope form this time, and then we'll get in slope-intercept form. So y minus y1, I'm going to use these points here, no decimals. x1, y1. Y minus y1 equals m times x minus x1. Distribute the negative 10, I get negative 10x plus 30. And if I subtract 6, I get negative 10x plus 24. However, we're going to use function notation. H of x is negative 10x plus 24. All right, guys, that is it for the chapter test portion. I'm now going to go on the cumulative assessment, in which case I'm probably going to lose some of you folk. It depends on what you're working on and what you got. But I got 9 more questions to go with here. Remember, it'll have questions from chapter 4, but also from chapters 3, 2, and 1. I might not remember how things were covered at the time, even though I know how to do the information, hopefully. Some of these questions get a little weird, I think. So let's see what they got for us. Number 1 says, which function represents the arithmetic sequence shown in the graph? Clearly, that's something from this current chapter, the most recent section. Let me kind of write it out based off what this is. Our first term is 24, second term is 21, third term is 18, fourth term is 15. We have a first term of 24 and a common difference here of negative 3. So I'm looking for something that might say a sub n equals 24 minus 3 times n minus 1. But if they, and I haven't looked at the options, but if they distribute negative 3, it'll say a sub n equals 24 minus 3n plus 3. And then you combine like terms, you get negative 3n plus 27. Let's see if this is one of the options or if that's one of the options. They wrote them with the other term last, so 27 minus 3n, therefore option C works out. Remember, this is all, commutative, so you can work that out that way. That's going to be it, option C. Number 2. Which of the inequalities are equivalent? For me, it's all about solving these guys. Which ones will give us the same set for x? So we got to kind of do each one. We have 3x plus 6. This is chapter 2. 8 plus 2x. If I subtract 2x from both sides and subtract 6 from both sides, I'm going to be getting x is less than or equal to 2. So keep that in mind for the first. I'll call this A. B, and put them side by side. 5x minus 5 is greater than or equal to 7x minus 9. I'm going to go ahead and I'm going to subtract 5x from both sides. Add 9 to both sides here. And now we got a 4 here and a 2x here. If I divide both sides by 2, I get that. But if I flip this over, that's x is less than or equal to 2. So A and B are actually the same. So which of the inequalities are equivalent? So far, these two are. Boom, boom. Connect them up. Let's look at the next one. Hopefully all of them are the same. That'd be fun. 12 minus 3x is less than or equal to 18. If I subtract 12 from both sides here, this 3x is still negative, which is important for flipping the inequality, right? If you remember that. Divide by negative 3. Now, a couple things happen here. Turns negative, and this becomes greater than or equal to. So negative 2. Not the same as those, but we'll see how it compares with D, which has a fraction. So what I'm calling D, at least. D has negative 2 minus 3 halves x is greater than or equal to negative 3 minus x. Now, I don't want to deal with the fraction. I'm not going to. I'm going to make everything 2 times bigger. Times 2, times 2. Fraction be gone. We got, in fact, let's do times negative 2. Everything's negative. Let's turn it all positive. Keep in mind, that'll flip the inequality. So this is positive 4, positive 3x, less than or equal to positive 6, positive 2x. Everything is doubled, sign changed, inequality flipped. So much better looking, wouldn't you agree? They were all negative to start with, right? Yeah. I'm going to subtract 2x's over, turn that into an x, subtract 4's over, and get our final answer. We are going to get x is less than or equal to 2, and that actually matches, I believe, with the other ones. Yep, so like A, B, and D, if you will, are the same, and this one is a little bit different than them. All right, that's what cumulative assessments do to us. Number 3. Complete the table for the 4 situations below and explain your reasoning. I'm going to copy and paste that table and see if I can fit everything there that I need to. I see the words correlation and causation, therefore I'm thinking chapter 4 here. Situation A, the price of a pair of pants and the number sold. Is there a correlation? Absolutely. The price of a pair of pants and the number sold. You sell, I think I got bit. You sell more, the price of a pair of pants and the number sold. I feel like the greater the price of pants, the fewer that will be sold, right? You raise the price there. And that's causation too. To me, it's like you raise the price, you're going to sell less. That's the idea. Assuming the same kind of pair of pants. The number of cell phones and the number of taxis in a city. I don't think there's necessarily a relation there. If there's a link, great. I'm not seeing one that necessarily there will be. Do the people in New York have a lot of cell phones? Sure. So do the people in Los Angeles. Well, I guess they have a lot of taxis as well. But, you know, it's just, I wouldn't find links there. And if there's no correlation, there's also no causation. A person's IQ and the time it takes a person to run 50 meters. No. I wouldn't call that related whatsoever in any sort of way. Absolutely not. I don't think I need to explain that one, guys. This says explain your reasoning. I'm going to go without an explanation on that one. The amount of time spent studying and the score earned. Now, I've mentioned something with this before. Would you link causation? I mean, correlation, yes. I'd say that there's a link, right? The more you study, then all that kind of stuff. And studying in general should directly link to some sort of score. Are we poor test takers and stuff like that? Sure. But the idea of studying is knowledge gained. And I think they want to kind of lean into that. Some of these can be absolutely argumentative. I'm going to state that you get more of that studying in, more knowledge is gained. So causation, yes. One is causing the other to happen. And I can see where these can be argumentative in such a way. This is why I'm not a great stats teacher. So I'm just going to go ahead and lean into that and say, yes, that'd be true. Number 4, consider the function and select the functions that are shown in the graph. So I think this was from chapter 3 because I'm seeing things that are transformations. So I think we're going to have to, you know, pop this up. I think even the other part, I want to get everything involved in here. So I'm going to copy paste this whole thing. Let's get this shrunk to size. Let's see what they're talking about. I don't know if that's much bigger than what you see on that other side. Sorry. I thought this was going to be a lot bigger, but I guess not. Okay. So the original one is f of x equals x minus 1. Now that does mean, if you recall, a y-intercept of -1. Oh, where is it? Excuse me, y-intercept of 1. Well, I guess it's not on here. So I'm going to draw it. It's a y-intercept of -1 and a slope of 1. So it's going to be like a rise over run that looks like this. And that's the f of x equation. So let's compare all the other ones to that as a result of it. Are they saying select the functions that are shown in the graph, explain your reasoning? I don't know if that means like, hey, this is green and stuff like that, but I'll try. So g of x equals f of x plus 2. Oh, here's what I'll do. I'll label them over here. F of x plus 2, this means we got to translate 2 to the left. Oh, I don't know if that's green yet. I think it is green, though. So we translate to the left of this guy. If we consider any point right here, 1, 2 to the left is that in green. So this will be g of x in green. I'll write this in black for now until we get there. H of x equals f of 3x. If you recall, something on the inside here is also inverted. This is a horizontal compression. Horizontal compression by a factor of 1/3. Everything is 1/3 skinnier than it was before, although the y-intercept will stay the same. So that looks like the red one. So this is h of x. Is that right? Yeah, horizontal compression. So it's 1/3 skinnier in that way. K of x equals f of x plus 4. We're going to go 4 up from that one. So find the one that from black goes 1, 2, 3, 4. That's purple. So that will be k of x. P of x is f of negative x. You're going to flip this thing over horizontally across the y-axis. So reflect over y-axis. So that means that it's going to keep the same thing. I don't think I see that answer on here. If reflected over the y-axis, it would go this way. I don't think I see p of x on there. So I'm just going to say it doesn't exist for now. Oh, I guess it won't. I guess there are only so many on here, right? So that one's just not on there. Just kind of leave it. 3 times f of x, r of x 3 times f of x. This would be a vertical stretch by a factor of 3. Now, you could argue that, oh, it's got a slope of 3. It's going to be the same as this. Yeah, but everything else would be 3 times bigger. Then this would be an equation that's r of x equals 3x minus 3. And I don't see a y-intercept of -3 down there. So that one doesn't really work either. I'm going to say that's not on here. Therefore, hopefully this last one's on here. Q of x is negative f of x. This is reflecting over the x-axis. That means the y-intercept also flips over as well as the slope. So you see what's in black here. I think that's in blue, reflecting over x-axis. Boom. I'm going to call that one my Q of x. So I think all of them are now labeled because this was the original f of x, and that seems to work out to me. So that's that guy. Okay. These other ones didn't really apply. It scared me for a bit. I thought they all had to match up, and I'm like, I don't see one. All right, number 5, use the numbers to fill in values for m and b in the equation y equals mx plus b so that its graph passes through those 2 points. All right, well, I'm going to do the work. So 6, 1, and -2, -3. Let's start with a slope, good old-fashioned. Let's do, I'm going to run, so let's do y minus y1 over x2 minus x1. I want my run to be positive. 1 plus 3 is 4, 6 plus 2 is 8, 4 over 8 is 1/2. So far so good because 1/2 is in our set, but our y-intercept, let's go off of slope-intercept form. Y equals mx plus b. Let's plug in 6 and 1 in here. 1 equals half of 6 plus b. Half of 6 is 3. 3 plus b is 1. Subtract 3 from both sides. We get a b value of -2. All right, so our equation is going to be y equals 1/2 x minus 2. That's the answer. I can see 1/2 right there and -2 right there. So those work, and those are the values. I mean, they try and make it tricky, but you just solve it, and then you just kind of say, are the numbers in there? They are, so we're good to go. All right, it's possible that I'm going to be finishing this within the hours. We only have 4 more questions, but who knows how these numbers go, right? They can just be so wonky. But 6, 7, 8, and 9. Number 6, the equation of a line is x plus 2y equals 10. That's standard form, by the way. Do we want to keep it in standard form? Let's see. Use the numbers and symbols to create the equation of line in slope-intercept form and passes through the point and is parallel to the given line. So here's our line right here, right? If I get this in slope-intercept form right now, that'll be helpful for me because I can reveal the slope of this equation even. So if I divide this all by 2, that means these all divided by 2. Negative x over 2 can also be written as negative 1/2 x. So here's this equation rewritten in slope-intercept form, which is important because this extracts the slope of negative 1/2. We need to be parallel to this, so we're going to use this negative 1/2 slope in the go-ahead. We need to go through for negative 5. So if I substitute negative 5 for a y, 4 for x, I can get a b. We literally just did this with the other problem as far as solving for b, plugging in some values. Add 2 to both sides, you get a b value of negative 3. So our equation with this slope and this y-intercept will be y equals negative 1/2 x minus 3. That is the part A for this question here. Part B says use the numbers and symbols. Oh, use the numbers and symbols. I'm sorry. Let's see if we actually had those. Negative 1/2 is right there. So y equals, here's an x, negative 1/2 x minus 3. All right, they're all there. It doesn't mean it's correct, but I think what I did was correct. Part B, use the numbers and symbols to create the equation of the line slope-intercept form that passes through 2, negative 1, and is perpendicular. So we have the same equation from before, but the perpendicular opposite reciprocal slope will be positive 2 over 1. This time I'm going to go and use point slope form, guys. We're going to go through 2, negative 1, so I'll say y minus y1 equals m times x minus x1. It's been a minute that we've used this. Let's distribute the 2 over and subtract 1 over. See, this goes fast. This y equals 2x minus 5, and all is good to go there. Is this good? Y equals x. Here's 2, minus, and 5. Okay, good to go. I didn't use any of these ones. Yup-de-doop-de-da. All right, number 7. You claim you can create a relation that is a function, and your friend claims that she can create a relation that is not a function. Yeah. Using the given numbers, create a relation of 5 ordered pairs that support your claim. What relation of 5 ordered pairs can your friend use to support her claim? So for me to create ones that are a function, remember, they don't need to go in a line, guys. Do they? A relation is a function. No, as long as I have different x values. So me. Oh, but they said use the numbers. I don't know if I'm allowed to repeat numbers or not. Well, there are only 9 of them, so I'll do as well as I can here. Using the given numbers, create a relation of 5 ordered pairs. I don't know. I'm going to try and not repeat as often as I can. Let's go negative 4, comma, negative 3, negative 2, comma, negative 1, whoops, 0, comma, 1, 2, comma, 3, and I guess I'll repeat something, 4, comma, 4. Here's the thing, my x is never repeated. X is never repeated, so mine is a function. For them to create something that's not a function, they need the same x value each time. So friend, we have to repeat our x values. Now, does it need to be not a function for does it need to repeat x's all the time? No, not at all. Just once. So how about 2, comma, negative 4, 2, comma, negative 3. Boom, not a function anymore. Okay? Now, let's try and just use every other number here. Negative 2, comma, 3, negative 1, comma, 4, and 0, comma, 1. Boom. Now, this makes it not a function because different, same x value, different y values there. And that's what the friend's doing. That's from chapter something. Chapter 3 was on functions, right? Number 8, you have 2 coupons you can use at a restaurant. Write and solve an equation to determine how much your total bill must be for both coupons to save you the same amount of money. So 20% off your entire purchase begins the first part. $5 off any meal of $10 or more. So if I have a meal, let's see. I have to think about this. So for number 8, so I'm thinking money saved, okay? If X is the amount of money I save in dollars, if X is the amount of money I save in dollars, I take 20% off of that, then 0.2 times X is how much money. Sorry, if X is the... save you the same amount. If X is the cost of my meal, 0.2X is the cost of how much money I save. To save me the same amount, I save $5 off any meal of $10 or more. I'm just going to set this equal to 5 because this is $5 saved, period. As long as this X is $10 or more, then this will be satisfied. If it's not $10 or more, then it's whatever. If I divide by 0.2, is that 25? I get X equals 25 for that one. So $25 is that. And is that $10 or more? Yes. So that's going to work out. I think that's all I do for that one. I don't even know what section. I think that must be from chapter 1 because it's equations. I don't know. The last question here, number 9. The table shows the daily high temperatures in degrees Fahrenheit and the numbers Y of frozen fruit bars sold on 8 randomly selected days. So it sounds like a scatter plot, sounds like our current chapter. The equation Y equals 3x minus 50 models the data. So Y equals 3x minus 50, as long as I don't have to do residuals. Oh, residuals. All right, they're here. All right, so Y equals 3x minus 50. Let's copy and paste this table then. Of course, they end on a problem that makes me question whether or not I'm going to finish on time. I think I will. By on time, I say within the hour. I like within the hour for my chapter tests and cumulative assessments and reviews. Okay. Select the points that appear on a scatter plot of the residuals. So for the residuals, what we need, guys, are the difference between our model set, what I call Y hat, and the Y and the Y hat here. So I need basically to substitute. See, I wish these were in order and that I could do this without like a difficult plugin process. Because now I got to do 3 times 54 minus 50, etc. This is where, honestly, guys, I'm going to go to the calculator. I did this for the review as well. But I'm going to go to this thing right here. I'm going to create an equation that says 3x minus 50. And I'm going to substitute these values in for x. I'm going to make it a little bit easier for myself. We're going to ask for these values. And our x values that we have here are 54, 60, 68, 72, 78, 84, 92, and 98. I have to save 98 for 1 second. Let me write these ones down because otherwise I won't have enough room. So I have 112. Really? That's far off from the answer. 130, or it's far off from the actual frozen fruit bars amount. So this model might not be very accurate. 154, 166. You'll see these numbers in a bit. 184, 202, 226. So that one's kind of close. And then 180, if I plug in 98. So 98, I'm going to get 244. Okay, so these are the numbers that I'm getting here so far. And you know what? I guess that aligns with the residuals that you see as options. These are really far apart from each other. I'm going to start drawing some lines here so you can look at these. How far apart is 40 from 112, 120 from 130, etc.? Those are the residuals. That's what we're actually going to subtract here, guys. Oh, that looks hideous. Oh, that looks hideous. Let's try that again. Okay. Normally I wouldn't do this for my tables, but I wanted you to see what we're doing specifically. So 40 minus 112, right? That's negative 72. So what I'm trying to see is 54 comma negative 172 on here? Is it one of the sets? 54 negative 70, it is. So that's one of the, that's one of the answers. Now I'm not going to go one at a time like that just yet. Let me do the actual subtraction. 120 minus 30 is negative 10. This is 26. 94? 96, I think. 58, negative 6, and negative 64. So let's keep checking these ones. This with this, etc. 60 comma negative 10. I'm only hoping I'm doing this right. If I have it on there, then I know I did it right. You know what I mean? Or I feel like I did. If it's not on there, I'm going to question it. 68 and 26. That's on there. Maybe all of them are on there, and we're just not doing the ones that aren't, if that makes sense. 72 and 94. Yeah, I feel like they all should be on here. 78 and 96. Oh, yeah. Look at that mental math work. I used the calculator for the other parts. 84 and 58. So, okay, I guess 2 won't be on here. You know what won't be on here? 60 comma 10, because 60 was already on there for another one. Anyway, 92 and negative 6. Oh, yeah. And then the last one, 98 and negative 64. 98 and negative 64. 96 never would have been on here, right? Because x, that wasn't an x value. So those ones are on there. Those are the ones that we select. That's part A. Part B says determine whether the model's a good fit for the data. It looks like it's not. I mean, here's the thing. I don't think it's a good... Okay, I didn't draw this graph, right? But besides the fact that those things are so far off, that's really what I was looking at. Now what I'm also looking at is how the residuals work. And I'm not going to do like a true blue graph of this thing here. But the idea is, guys, we have some negative residuals to start with down here. Like even at, this is like 54 and stuff. I guess these are increasing, though not by an equal amount. But it's negative here, and then it goes positive. You don't want this kind of thing where it goes positive and negative with that like U shape like that. That's a different pattern that resembles something that's not from a linear set. If it was more scattered, hey, 4 are above, 4 are below. Maybe we can make an argument that it's a weak fit, but it still is a fit for our data. It's the best line possible or whatever. But this is not a trend. Not that I plotted these exactly, but this is not a good trend for this kind of thing. The residuals form a curvy pattern. That would not be good for a good fit for a linear model. Therefore, this model is not a good fit. Well, I just said that. Therefore, no. So, yeah, nope. Yep, nope, yep, no, yep, nope. And that's all I'm going to say on that. You could go ahead and plot them and see for yourself, but I think that's what I'm going to state on that one here. That is part B, and I am good to go. Hey guys, so that ought to do it for this one. This is Mr. Robinson. Thank you so much for watching. This closes Chapter 4, as that was Cumulative Assessment, had some things on Chapter 4 as well. Next we go to Chapter 5, and I believe it's on systems of equations. I'm going to give you the heads up right now, and I'm going to talk about it when I start Chapter 5. This is around the time that I do for my classes anyway. You know when I like subtract things from both sides of an equation, divide things from both sides of the equation, that I write the action? I'm not going to write the action anymore. The book stops doing it at this point. You've seen it there. I'll say it out loud. Did this guy win? I don't know what's going on. I'll say it out loud, but I'm not going to do that anymore. I'm just going to have, if I subtract 2 from both sides, it'll just magically be subtracted by 2. I'll write the next step, okay? At this point, we want to work toward efficiency. I'm going to start doing that for myself. I do it in my IM2 and IM3 videos, so I got to progress to it at some point. I think we're at that stage now, because after this set, we go into more geometry. So I want to make sure I do it there in the solving systems of equations. So guys, that'll do it for this one. This is Mr. Robinson. Thank you so much for watching. Take care, and I'll see you in Chapter 5.